Okay, so in this this video lesson, we are looking at the first topic of the second part of the solutions unit, where we are studying some of the quantitative properties of solutions. So one of the first topics is or activities is to get a solubility curve of a solid. So in this case, it's the solubility curve for potassium nitrate. Okay, and the idea was to basically change the amount of the amount of solid that's in a particular volume, okay, which is known as the solubility. So the mass of the solute in 100 grams, okay, and then test it out and figure out what temperature it's saturated at. Okay, so this is what we were measuring, is the temperature. Okay, and you should end up getting a graph that looks much like this. It might be a line, it might be more of a curve. Okay, now generally we're not supposed to actually graph it this way. We should put the solubility here because that's what we were changing, and then the temperature because that was the response. But all these graphs are always done with temperature along the bottom and solubility along the vertical. Okay, and that really is, this would represent 100 grams of solute dissolved in 100 milliliters of the water. Okay, so you get a graph that looks like this, where most of the time, as the temperature goes up, the solubility goes up. Not always, but most of the time it does. Okay, so that was the first activity. Now what we're going to do is we're going to summarize it. Okay, so we're going to summarize this activity, and this is a note. This is actually a set of data that was done several years ago. Quite good data, okay? And basically we're going to illustrate what this graph actually means. Okay, so the line represents the maximum amount of solute that can dissolve in 100 milliliters of water as temperature changes. So obviously as temperature goes up, the solubility goes up, okay, in this case. But there's two other regions that are important. There's a region below, okay, that represents a type of solution, and a region above that represents a type of solution, okay? So the line represents one type of solution. That's the maximum amount. That's known as the saturated solution, okay? If you're below the line, then you don't have as much solute that's dissolved, so you have less than a saturated solution or an unsaturated solution, okay? Finally, and we can use some colors here to help us out, if we're above the line, which doesn't really make a lot of sense, a maximum's a maximum, but there are some situations where you can get a solution to have more solute than there really should be in at that temperature. They're unstable, and if it does happen, we'll call this a supersaturated solution, okay? But it really is not a possibility in most cases. Most of the time, you will have a saturated solution only, okay? So if you get into this region, okay, so say somehow you had a saturated solution, you cool it slowly, this is how you do it, okay? You have more than you should, probably by the height from the curve. So say we're looking at 90 degrees, that's about 150-ish, okay? And if we cool it down by 10 degrees at 80, it should really only have about 100. So there's an extra 50 grams of solute that's dissolved in there. Once it becomes so unstable that it can't hold that extra, all that 50 grams is going to become a precipitate, okay? And then it'll return back to this saturated solution. So this is really something that doesn't happen very often. Okay, so as a note, we can look at our note here. Okay, basically we have three regions, okay, and I've color coded it. So below the curve we've got a solution where there's still more space for solute to dissolve in, okay, and in the solvent at a given temperature. Okay, along the curve or the line, this is a solution where it's a saturated solution. It's where the maximum amount of solute is dissolved in a given volume of solvent at a given temperature. And then finally, if you do get into that region above the maximum, that's known as a supersaturated solution, which is very unstable and shouldn't really exist, but it does happen the odd time under certain circumstances. And generally it's cooling something that's saturated slowly, okay? and you can't cool it too much. But basically, more solutes dissolved in a given volume than there really should be. Okay, that's our three regions. Okay, and I gave this a title of solubility curves just as our note. Okay, so we use this graphic to actually help us figure out what type of solutions we have, and actually maybe be a little bit more quantitative as well. Okay, so we're going to do an example using this sheet here. Okay, so we're going to do two examples here. So number one, we'll just do figuring out whether we've got an unsaturated, saturated, or supersaturated solution. So we're looking at potassium chloride, so that's this curve right here. Okay, and we're looking at 60 grams at 70 degrees. So I like to look at the temperature first. So here's my 70, and then I'm going to go to 60 here. As you can see, it's above the line, the KCl line. So if it's above the line, it's going to be supersaturated. Okay? Technically, like I said, that's not going to exist for very long. It's unstable. Technically, there should only be about 50 or 48 grams at 70 degrees. So there's a difference of about 12 grams. Okay? And that represents how much solid should dissolve by the end of it, or it should become undissolved at least. Okay? So that's what we have. Supersaturated, or 12 grams becomes undissolved or precipitates. Okay. Next one that I want to look at is 12. Okay, so a little bit more quantitative. So it says, what mass of potassium chloride, so we're looking at that one again, is needed to form a saturated solution if KCl was dissolved in 200 grams at 80 degrees. Okay, so first of all, our graph is for 100 grams. So we got a little bit of work to do here. So we're going to look at potassium chloride at 80, and it looks like it's about 50 grams. Okay, so we got 50 grams of the potassium chloride, 52, that's dissolved in 100 grams of water. Well, it makes sense that if we have double the amount of water, we should double the amount of solute that's present in there, and that will still give us the same solubility. And that's really what we're doing. It's 50, and it's just proportional reasoning here. So it's 52 grams of potassium chloride in 100 grams. If we get double the amount of water, then we should have double the solute. So 104 grams of KCl. Excuse me. All right, last thing is just a term that you may be unfamiliar with, and that's more concentrated. Concentrated is going to be a term that we'll use a little bit later. Excuse me. And basically it just means if it's concentrated, it just means there's a lot more in a certain amount of volume. Okay, and that can happen different ways. You put more solid in the same volume, or you reduce the volume and keep the same amount of solute. So what I'd like you to do is to complete these questions, and then we'll also look at this excuse me, this other worksheet as well on both sides. Okay, thank you.